A view of the Devil's Woodyard from 200 feet. We can clearly see the lines of active mud vents. In this shot, we are looking north, and in the background, we can clearly see the Central Range. In this view to the south, the Rock Dome Anticline and Trinity Hills are visible in the distance. We see that houses are relatively close to the mud volcano. On this Google Earth image, we have plotted the July 2020 vent locations. It is clear that the vents have a semicircular distribution, similar to the concentric rings seen on the Tasik. Good morning, we are at Devil's Woodyard. It's the 1st of July 2020. The first thing we notice is that the erupted mud has compacted significantly. First, let's look at our sign, which basically tells us be careful. We're now visiting the mud volcano, which is basically 3 months after the site was closed. What we see now is that the cones have grown significantly in height because people have not been interfering with them. So we also see that a number of the old cones have died. We see liquid mud being ejected with a few little bubbles. See, this mud is fairly liquid. And it's just the tiny vents. So here we have a long line of vents which corresponds to a linear feature that we saw just after the eruption, and this also existed prior to the 2018 eruption, so it probably represents a fault along which this mud is coming up. Black scum on the mud probably represents oil. One thing we will see today, either the mud is very liquid or very viscous, as we see here. So let us walk towards the central cone, which has grown significantly in height. But first, let's look at the ground on which we are walking. We see that there are a significant number of clasts on the ground, so that represents some kind of calcareous material. This pebble is a rounded chert which is originated from the Sepero. We see some sandstone, we see some mudstone concretions. So the surface is littered with clasts. So fine sands like these represent Herrera sands that have come up from the reservoirs. Flowing out of this particular vent. There are just a few bubbles coming up. In this panoramic shot, we see a line of cone and vents on the eastern side of the task. On the southern side, we see another line of cones and vents. Here in this photo, we're seeing the concentric distribution of active vents and cones. In this photo, at the center of the tussock, we're seeing again the concentric distribution of active vents and cones. Here's an image of the largest cone, which is located at the center of the tussock. The COVID-19 lockdown instituted in early March 2020 and the consequent closure of the park to visitors had a tremendous positive benefit to the area. The cones, especially the one in the center, was able to grow in height from about 1 foot to 3 feet. It also developed a much larger base. Other cones have shown similar developments. We see here a fairly large chute. So this vent here apparently was vandalized last night, which would have been the 30th of June 2020. So our individuals whose sole purpose is to destroy everything. So they attacked a number of vents. We see a second one, a third one, and finally this one here. What they're looking for, these individuals alone know. In these graphs, we are looking at a number of active vents. Firstly, between 2003 and 2020. What we see is that pre-eruption activity levels were gradually decreasing from a peak in 2008. Post-eruption, we see that activity levels are fluctuating, but are still high. Let us take a quick look at how the distribution and location of activity has changed between February 2018 and the 1st of July 2020. Starting with a single mud vent in February, it grew to as much as 156 at the end of December in 2019. What we see, there are apparently 3 trends. One which goes from southwest to northeast, one from northwest, actually 2 from northwest to southeast. And we start seeing a circular pattern appearing which corresponds to the rings on the tussock. Here we are comparing the location of the July 2020 vent locations against those pre-eruption 2012 to 2017. We see that the activity is essentially taking place in the same areas. Here we have surface geology maps from UBOT and a 50,000 Kugler sheet that are very different. One has two vents at Devil's Woodyard while the other has one. The shapes of the area covered by the mudflow and even the orientation and location of the faulting is also different. Devil's Woodyard is located, however, near the crest of the Mandingo anticline, but is not associated with any thrust fault as has been suggested by some persons. In this drone photograph taken in August 2018, we see there's a linear subsidence going across the tussock of the volcano, as well as to the right, the ground surface has been displaced. Displacement was also noticed in the vegetated area on the left. In the sketch, we see that the increased number of new vents parallels the subtle linear features seen in the previous photograph. And it is also continuous with the southwest and northeast trending fractures. So we see that pre and post eruption mud vent activity does not correspond to any of the mapped legacy faults. Here we see that has been weathered out of the mud. Fairly large block of parallel laminated sandstone. Lots of well-rounded chute. The only other place we see well-rounded chute such as this is at the Four Roads Tamana. Thanks for watching this video to its end.